So today, we're diving into something that is honestly pretty mind-bending. We're talking about how scientists are teaching AI the fundamental laws of physics, and even more amazing, how AI is starting to discover those laws all on its own. Let's get into it.
You know, when you look around, everything, from a swirling vortex in a fluid all the way up to the orbits of planets, is governed by these invisible rules. We call them the laws of physics. For centuries, it's been our job as humans to figure out the math that describes them. But what if we could flip that script? What if we could build an AI that could just look at a system in motion and figure out the deep underlying laws of physics directly from the data? Now that's the big question we're exploring today.
To really get how we get there, we first have to talk about a huge hurdle for traditional AI, especially in science. You might think AI is all about big data, right? But in a lot of scientific fields, getting data is super hard and really expensive. This is what we call AI's small data problem.
And it's not a small issue. As these researchers from Brown University and UPenn point out, when you don't have millions of data points to feed the machine, most of your standard state-of-the-art AI models, they just fall apart. They can't find a reliable pattern, and they basically just fail.
Here's a great way to picture it. A standard AI is like a student who's trying to ace a physics test just by memorizing thousands of old practice problems. Sure, they might do okay on questions they've seen before, but throw them a new problem, one that requires a real understanding of the concepts, and they are completely lost.
So the first huge breakthrough was to stop treating the AI like a cramming student, and instead, well, what if you just gave it the textbook? And this is where this brilliant new approach comes in. Physics-informed neural networks, or PINs for short.
Okay, so what is a PIN? It's a special kind of neural network that's trained to do two things at the same time. One, it has to match the data points you give it. And two, it's forced to obey a known law of physics that you've basically hard-coded into its training. It has to follow the rules.
And this is really the night and day difference, right? Your standard AI just memorizes patterns from data points. But a physics-informed AI learns from two sources, the data points and the physical laws. This makes it incredibly efficient with data. It's not just memorizing answers, it's actually starting to understand the rules of the game. So how in the world do you actually make an AI obey a law of physics? Well, it's pretty clever. You basically give it a two-part test while it's training, and its final grade depends on scoring really well on both parts.
Let's walk through it. First, the AI just makes a guess, an approximation of the solution. Then it gets scored on two things. Part one of the test is, okay, how close is your guess to the actual data points we gave you? And part two is the new trick. How badly does your guess violate the known law of physics? The AI's one and only goal is to get its error score on both of those parts as close to zero as possible.
And this is the secret sauce, right here. By forcing the AI to obey the laws of physics, it can't just randomly connect the dots. It has to fill in all the gaps between the data points in a way that is physically possible. The physics itself acts like this powerful guide, or what researchers call a regularizer. And check this out. This is the payoff. On the left, this is the input. Just 100 scattered data points from something called the Burger's equation. It's a really key model for things like shock waves. And on the right, that's the PIN's prediction. From that tiny little bit of data, it reconstructed the entire beautiful, continuous solution just because it knew the rules. It's absolutely incredible. Okay, that's amazing. We've taught an AI to follow the rules in the textbook. But hold on. What if we don't know the rules? What if the textbook is empty and the AI has to write it itself? Well, that's the next incredible leap. So this next evolution is called deep hidden physics models. Now, instead of one neural network, we're using two that work together. The first network does what we saw before. It tries to guess the solution that fits the data. But the second network has a much harder job. It tries to guess the unknown physical law that's actually governing all that data in the first place.
I mean, think about what this means. This is a total game changer. The AI is no longer just a student following instructions from a textbook. It's now acting like a research scientist, observing an experiment and trying to come up with the fundamental theory, the hidden physics that explains everything it sees.
So, the big question, does this actually work? Oh yeah, it works. Look here. On the left, you see the true dynamics of the system, the ground truth, and on the right, you see the dynamics that were produced by the equation that the AI discovered all by itself just from looking at that same scattered data. They are almost a perfect match.
And when I say almost a perfect match, I mean, check out this number. The model the AI discovered was over 99.5% accurate. It didn't just find something close. For all intents and purposes, it found the actual equation. Okay, but here's the skeptic's question, right? Did the AI really understand the physics, or did it just get very, very good at memorizing one specific pattern? To find out, the researchers gave it the ultimate final exam, a completely new scenario it had never seen before.
So, they took the equation the AI had discovered and they applied it to a totally different physical situation, a new starting point, which created a completely different wave pattern that the AI had never ever been trained on. This was the real test. And the result? It absolutely nailed it. The equation that it learned correctly predicted how this entirely new system would behave. And this is the proof. This is what shows that the AI didn't just memorize the data. It successfully extracted the fundamental, generalizable law of physics.
All right, so let's just quickly recap the big ideas here. First, traditional AI really struggles with the small data problems we see all the time in science. Second, physics-informed neural networks, or PINs, are a great solution when we already know the physical laws. And third, deep hidden physics models take that to the next level, letting the AI actually discover the unknown laws all on its own.
And the lead author on this work, Maziar Raisi, he really summed it up perfectly. This is a deep learning approach for discovering the equations of the universe from scattered, messy, and potentially noisy real-world data.
And you gotta understand, the implications here are massive. This isn't just some neat academic trick. It's a brand new tool that could potentially revolutionize how we model everything from climate change to material science. This is a truly disruptive new way of doing science.
It's kind of wild. We started by building AIs that could follow the rules we gave them. Now, we've built AIs that are learning to find the rules for themselves. Which just leaves us with this one fascinating final question. What new, undiscovered laws of our universe will they help us find next?